Greetings everyone, we will continue our discussion on programming and problem solving using C. In the previous session, we have started about the concepts of arrays. In this session, we will be looking about what is a pointer to pointer and also other related topics like pointer compatibility and pointer arithmetic. So in the previous session, we have started about what is a pointer. A pointer in a C language is a variable which will be used to store a memory location of another variables. Okay, the pointers are used to access the memory locations so that you can manipulate the data present in those memory locations. So as you have already seen, you can access the address of any memory location, you can access the address of any memory by using your address of operator or ampersand symbol by placing the ampersand symbol beside a variable. So you can use the address of any variable to access the memory address for that particular variable. Then we have seen your general memory will be present in this manner. If you declare a variable, the variable will be present, a variable location will be there. That particular location will be having a memory address. Okay, each and every memory location will be having a unique address, and A will be, that is the name of your variable, will be the name of your location, and whatever the contents of your location will be the value of the location. And if you are having a pointer will store the memory address of other variables. So since pointer is also a variable, it also will contain one memory location. So as you can understand, pointer is a variable. So since it is a variable, the variable also will contain a memory address, and this pointer variable will store the address of other variables. So it doesn't store normal values, it will store the address values only. Okay. So with this knowledge, we will go for the next topic, pointers to pointers. But already you have seen how to declare a pointer. You will be placing the data type space, and you will be placing the star to define that it is a pointer, and you give the name of the pointer. When I place int, it means that I am going to point to an integer value. If I place a float, I am going to tell that it is going to point to a floating point value. And you will be declaring your pointer, and you can initialize by using your address of operator. PTR is equal to address of A, that is, you can give the address to, you can initialize your pointer by giving the address, and if you don't have any value to give, you can initialize it to null, that we will be calling them as a null pointer, and you can dereference it by using your star operator. So you can declare it, you can initialize it, and you can dereference it by using your dereference or indirection operator. All these things you have seen in the last session. So in this session, we will be going for what is a pointer to pointer, and that pointer to pointers will be calling them as otherwise double pointers. Pointers are used to store the address of other variables of similar data type. But if you want to store the address of another pointer variable, then you again need a pointer to store it. What is the meaning of this is, initially if you have declared a variable A and you have given a value 10, so you will be having this memory location, and you will be having address of that particular memory location. And if you are having a pointer star PTR, okay, and if you initialize your PTR is equal to address of A, now what will happen? PTR will contain its own memory location, it will be having some memory address, and it will contain the memory location of the address of your A variable. So this will be PTR. Okay, now if you want to store the address of a pointer variable, that is, this is the address of a pointer variable. If I want to store the address of a pointer variable, then again you need another pointer to store it. Then you will need another pointer, okay, another pointer to store this address of the pointer. This pointers which stores the address of already existing pointers, will be calling it as pointer to a pointer. Okay, so how you can declare this pointer to pointers? Thus, when one pointer variable stores the address of another pointer variable, okay, if a pointer variable stores the address of another pointer variable, it is known as pointer to a pointer variable or double pointer. So your double pointer will be declared in this manner. So if a double pointer will be declared by using two star operators, okay, 2 stars means it is a double pointer, In the same sense, if I want to store the address of a double pointer, I can use a triple pointer. If I want to store the address of a double pointer, I will be using the triple pointer. Remember the levels. This is a variable level where the variable will be having the memory location. Then this is a single pointer level, PTR1, where the pointer 1 will store the address of A. Here P1 is a double pointer which will store the address of PTR1. P2 is a triple pointer where it will store the address of P1. That is, the triple pointers can store the address of double pointers. In this manner, you can be having more levels like this. Like this, you can have. Okay. So this P3 can store the address of P2. Okay. You can have direct P1 is equal to address of PTR. In order to initialize your P1, I can store the address of PTR. So these things will be calling them as a pointer to a pointer. If a pointer stores the address of another pointer, we will be calling it as pointer to a pointer or double pointer. This is an example of your pointer to pointers where initially you have given a value as 10. You have given a value as 10. Then you have declared two variables. One is P1, that is pointer, basic pointer P1. And you have declared a double pointer P2. Okay, remember this one is a basic point. This is basic pointer. This is a double pointer. P1 is equal to address of A. We have written P1 is equal to address of A. If this is 80F, this is 81F, this is 82F. These are the address values. P1 is equal to address of A, so it will contain 80F. Next, P2 is equal to address of P1, so this will contain 81F. Okay, P2 will contain the address of P1, so that will be 81F. After that, you are printing, first printf statement is print address of A is address A. That is, you are printing the address A. So the address of A is 80F. Okay, the second printf statement is address of P1. Address of P1 is 81F. Next, the third statement is address of P2, that is 82F. You can print the address by using your address operator. Next printf statement is value at the address stored by P2. What is the value at the address stored by P2? If I write, okay, so here you can dereference these values one by one. If I am writing star P1, it means that value at the address of A. Okay, value at the address of P1. Okay, when I write the star P1, that is the dereferencing operation. This refers to value at the address of P1. So value at the address of P1 will be 10. In the same case, if I write star P2, okay, it will refer to the value at the address of P2 which is present in this particular thing. So when you go for this statement where you are writing value at the address stored by P2, where you are writing star P2, that is one single star P2. Okay, one single star P2 will refer to value at the address of P2. So P2 will contain one address. What is the value present in that address? That is the thing which is trying to print. Value at the address of P2. That is, P2 contains 81F. What is the value that is present in 81F? That is 80F. That will be the output for your this line. Next, value at the address stored by P1. Okay. So here you are writing star P1, that is dereferencing P1. Dereferencing P1 will result in the 10. Star P1 means dereferencing P1, which will point to A, that will be 10 value. Value of star P2. Now star P2 will refer to two dereferencings. Okay, where the inner dereferencing is value at the address of P1, value at the address of P2, that is 80F. Okay, next, again you have to dereferencing, that is value at the address of 80F. Value at the address of 80F, that is 10. So that is how your star P2 will work, and star P2 means it will print this value, star P2 means it will verify your 10 value. So this is about your double pointers where you can declare more than one, where you can declare a pointer to another pointer. In the same sense, you can have triple pointers or 4-level pointers. So this is about your double pointers. The next topic is pointer compatibility. So the rules of assigning one pointer variable to another variable are tighter than the rules of your numeric types. Numeric types in the sense, so you are already having the numeric types, that is integers, float values, okay. So in this, if you are having something, a statement like this, A is equals to B or B is equals to A, both are valid statements, that is whatever may be the value that is in B can be assigned to A, and whatever the value that is present in A can be assigned to B. Okay, so even if you are having some value, this is 20.56 something. Okay, if I write A is equal to B, what will happen? The B value, that is 20.56, will be truncated and the integer value will move, that is 20 will move to A. Okay, in the same case, if A is 10, it will move as 10.00. Okay, so the normal numeric type conversions, whatever you are doing, you can assign one value to another. But the rules of assigning one pointer to another is more tough. So for example, if you can assign integer value to double value without using any type conversion. Okay, you can assign one integer value to one float value to integer value without any type conversion you can perform. But you cannot do the same for pointers, okay, of two different types. Okay, what is this meaning? If you take this example where you are having two variables, one is integer, one is long double, okay, then what you have done is you have created one integer pointer pi, and you are pointing to your integer n, and you are pointing to your integer n. Then you are having another double pointer pld, this is pointer to the long double, and this is pointing to your long double x. Okay, whatever may be the value, it will be pointing to long double x. Now, if you see, these are general variables, these are pointer variables. So these general variables, you can perform x is equal to n, n is equal to x, both are valid things. You can perform n is equal to x, x is equal to n, both are valid statements. But when you go for your pointers for conversions, or when you go to compatibility of your pointers, you cannot assign one pointer to another one. That is, you cannot use pi and point to a long integer, and you cannot use long integer and point to pi, long integer pointer and point to a integer. Both are not valid statements. So if you take x is equal to n, that is a valid statement. Or if you do n is equal to x, that is also a valid statement. But if I do pld is equal to pi, okay, pld is equal to pi, where pld is your long division pointer and pi is integer pointer. You cannot assign your integer pointer to long division pointer. That is one level of compatibility, where one pointer cannot be assigned to another pointer. In the same case, one pointer cannot point to a different data type. That is, this is an integer pointer. Integer pointer cannot point to a long double value. In the same case, one long double pointer cannot point to a integer value. So this is a time compatibility. You cannot perform these operations. Okay, these are incompatible operations, where one pointer cannot be assigned to another pointer and one pointer cannot be pointed to a different value. So the pointer has to be of same data type. All the pointers which you are assigning have to be of same data type, and whatever the pointers you are pointing to should match with your general variables. Whatever these extensions extend to more complex types as well. Notice that non-valid assignments all involve two pointers that don't point to of same type. So you will see an example where your pointers should not be pointing to same type. That is, your pointers should always have to point to the same data type. If they point to different data type, they will be giving you an error. So this is an example which explains all these issues. So you will be having three different types of compatibilities. One is the assignment. Okay. Another one is type of pointer. The third one is level of pointer. What is the assignment means? You cannot take one integer pointer and assign it for a long division pointer or a floating point pointer. What is the type of pointer means? You cannot take an integer pointer and point it to an float value. Or you cannot take a floating point pointer and point it to an integer value. And the level of pointer means you cannot take one level pointer and point it to a two level pointer. Okay. You cannot take one level pointer that is a normal pointer and point it to a double pointer like this. So the level of pointer also will matter here. So let's look at some examples where Pi is your normal pointer. Pa is an array of pointers where you will be array of 3 pointers. Okay. A pointer to an array of 3 integers. Next, you are having an array 1, array 2, then you are having a double pointer. So in this, if you see, Pi is equal to Pi, where Pi is a normal integer pointer, Pi is equal to address of array of 1, 0, 0. Here Pi is pointing to a two-dimensional array first element. Two-dimensional array. So if you see two-dimensional array, this will be 0, 0, 0, 1, 1, 0, 1, 1. So your pointer can point to a two-dimensional array. This is an integer value, it can point to a integer array. Okay. Next, your Pi can point to a one-dimensional array value as well. Since it is an integer pointer, it can point to a one-dimensional array. Next, if I perform Pi is equal to AR1, okay, this is not a valid statement. Why? Because Pi is an integer pointer and AR1 is a array of 3 integers. So AR1 is an array of 3 integers and your Pi is only a single integer value. Sorry, Pi is a single pointer. Okay, next, you are having Pa is equals to AR1. Pa is equals to AR1, where your Pa is a pointer to an array of 3 integers and your AR1 is an array of 3 values. That is 2 by 3 matrix, so it will be pointing to 3 values. So both point to int of 3. That is, your Pa will point to an integer of 3 arrays. Pa is equal to AR of 2. Okay, Pa is equal to AR of 2 is not valid. Why? Because this is 3 and this is 2. Okay, those things are also not valid. P2 Pi is equal to address of Pi. So this is double pointer which is pointing to a single pointer. Okay. Next, if I do P2 Pi is equal to IR of 0, that is valid. P2 Pi is equals to ARR of 2, that is not valid. So to reduce the confusion of all these things, if you see, okay, if I am having an integer pointer and an integer value, my pointer can point to the particular integer value. If I am having a, let's take floating point PTR1, this PTR1 cannot contain the address of A. This is not a valid statement. Why? Because PTR1 is a floating point pointer. The floating point pointer cannot point to the particular integer variable. The floating point pointer cannot point to an integer variable. this is one incompatibility, where your pointer and the pointing which you are doing should both be compatible. The second compatibility is you are having an integer pointer ptr and a floating point pointer ptr1. So you cannot assign one pointer to another. That is, you cannot assign an integer pointer to floating point pointer. This is also not compatible. Okay, this is the first compatibility where you cannot point one element with another data type pointer. Okay, this is another incompatibility where you cannot assign one pointer to another pointer, which are of different types. The third is if you are having a double pointer, star star ptr2, where this is a double pointer, and if I am having ptr2 is equal to address of ptr1, that is address of ptr, that is integer pointer, ptr2 is getting the address of ptr. Now I cannot use this particular double pointer and point it to a triple pointer. For example, if I am having star star ptr3, okay, I cannot use ptr3 and point it to the first pointer, that is ptr. I cannot use the triple pointer and point it to this ptr, that is the first level of pointer. So a pointer to a pointer can point to ptr, but your triple pointer cannot point to your first basic pointer. So those are the levels of pointer, that is the second level pointer can point to the first level, the third level pointer can point to the second level. So you should not be mixing up these things. So these are the three incompatible types which you will be having as a part of your pointers. So you should be matching the same data type pointers, and you cannot assign different data type pointers, and you cannot assign different level of pointers. That is regarding your pointer compatibility in C language. The next thing is your L value and R value. So an L value, this is another topic regarding your pointers. One is an L value is a locator value represents an object that occupies some identifiable location in the memory, like an address. Okay, you can think of your L value as your LHS, that is left hand side of your expression. Okay, you can think of your L value as your left hand side of your expression, where it represents an object that occupies some identifiable location in the memory. Okay, so whenever your LHS is present, this will be usually the L value. Why? Because the end result will be stored in your LHS or your L value. So the end result should always contain some memory location. Okay, whenever you are writing something in the expression, the end result will be on the left hand side. That will be usually the L value. That L value should generally occupy some memory location or the memory address. R values are identified by exclusion. So an R value is an expression that does not represent an object. That is, all the values which are not L values will be R values. Those statements or those expressions which are not L values are usually called as the R values. Every expression is either an L value or an R value. If you write some expression, it will be either an L value or an R value. For example, if you are having a simple statement, A is equals to 10. Okay, where your 10 will be the R value. Why? Because it doesn't have any memory location. 10 is a simple constant. It doesn't have any memory location. While A is a variable which is having some memory location and it is receiving some data. So this A is your usually the L value expression. But 10 is not a L value expression. Why? Because it doesn't occupy any memory. So it is a R value expression. So in this simple expression, this will be the L value. This will be the R value. Okay. So I will show you an example of which are L values and which are R values. Remember that L values can appear on the left hand side of an assignment operator, while R values are usually appearing on the right hand side operator. So the L values usually appear on the left hand side and R values usually appear on the right hand side. Okay, but I will show you some of the examples which are L values. The L value is one of the following. The first one, the name of the variable of any data type. Okay, that is an identifier of an integral, floating, pointer, structure or union. Any variable which stores some memory will be L value expression. Okay, variable is an L value. Second one, a subscript expression that does not evaluate to an array. Okay, a subscript expression, that is if you are having an array, so some 5 values, this is an array, and A of some value, A of 3 will represent the 4th element in the particular array. This subscript expression will represent an L value. Why? Because if you want to give value into this particular location, I will be using A of 3 is equals to 10. At that time, in that array, this particular 4th element, that is 0, 1, 2, 3, 4, this will be the indices. The 3rd position will get the value 10. So this is the left hand side expression. This is the array subscript expression. So this array subscript expression will get the value. So, and it has a memory. That is why this is L value expression. And it doesn't have any memory. This is R value expression. Your constants are usually R value expressions. Apart from that one, the unidirection expression that does not refer to an array. Okay, for example, you are performing your unidirection, that is, you can assign value, that is, if you are having a pointer in star A, and if you are having a variable int x is equal to 100, and you are using A value to get the address of x. So this is about the pointers, where you will be having a pointer and a general variable x is equal to 100. A is equals to address of x. So A is the pointer variable where you will be getting the address of x. So x is the variable, general variable, and you are having value 100 in that. And if this is the address, you will be having 80f. Okay, and if I am performing the indirection operation, okay, so value at the address of A, is 100, and if I am giving some value 10, so 10 is value at the address of A is equals to 10 means whatever the value that is present before will be removed, and the 10 value will be moved into the value at the address of 80f. Okay, your indirection operation can also be present as a part of your L value expressions. Next, an L value expression is a parenthesis, that is, you can have some parenthesized expression on the L value. Okay, next, a constant object or a non-modifiable object can also be an L value. The result of an indirection through a pointer, provided that it isn't a function pointer. Okay, so similar like an indirection pointer, indirection operation, you will be having this particular L value. The result of member access through pointer, that is, in structures you will be having your student1 dot marks. You will be writing this member access operator, that is s1 dot marks. In case of pointers, you will be using arrow operator. Okay. In case of pointers, you will be using the arrow operator. When you are having structure pointers, you will be having this arrow operator. At the time, S1 marks is equals to 100. So these are L value expressions. Okay. And remember, your L value expressions can appear on the right hand side. So for example, if you declare a variable A, okay, this is a general expression, and A is equals to 1. A is equals to 1 means where this is an L value expression where A is the L value and 1 is the R value expression. If I write B is equals to A, as you have seen, A has appeared as L value in the previous statement, and here you have written B is equals to A. So now A has appeared on the right hand side of your expression. So your L values can appear on the right hand side as well. Okay. So in the previous statement, when I written A is equal to 1, at this instance A is the L value expression, A is the L value. In the next statement, if I write B is equals to 1, at this time A is your right hand side expression. A is present on the right hand side. So your L values can appear on the right hand side as well. Okay, when I write large expressions like this, A plus 2, some large expressions, at this instance A is your L value in the previous statement. So L values can appear on the right hand side. But 2 is the R value expression. 2 is a R value. But B again became a L value expression. Why? Because A and B has memory, but your 2 value doesn't have any memory. So when I write something like this, 9 is equals to A. Okay, this is not a valid statement. Why? Because the 9 value cannot, when in an assignment operator, the right hand side value has to be moved into the left hand side expression. So the 9 value doesn't have any memory, so it cannot hold any value which is receiving it from the right hand side. So what you have to do is, in an assignment operation, always the left hand side will contain one L value expression. Okay, the left hand side should contain and will contain an L value expression. Your right hand side can contain L values plus R values. So this is about your L value and R value expressions. So your L value expressions are those expressions which are having some memory location and they are present on the left hand side of your assignment operation. Your R values are those expressions which are not L value expressions and they will be present on the right hand side, but your L values can appear on the right hand side as well. So this is about your L value expressions and R value expressions. Okay, in this session we have seen about this, what are the basic concepts regarding your pointers and what is a pointer to a pointer, and also we have looked about what is L value and R value expressions. In the next session we will be looking about more related topics of your pointers and other topics. Thank you.